everybody. Thank you so much for joining us tonight for another edition of what we've decided on the name as for Space Club. I'm Dr. Tanya Harrison, and we've got Dr. Phil Stooke. I still don't know those mirror directions here, and Dr. Danny Bednar. Tonight, we're going to be talking about what's coming up in the next year for planetary exploration, which I think we could all use right now because we could really use some escapism from our own planet. So Phil gives a presentation at the beginning, or I guess used to now that you're retired. But when Danny and I were students at the University of Western Ontario, the highlight colloquium of the year was always Phil giving his roundup of space missions at the very beginning of each school year. And so we figured we would revive that tradition online here. So Phil's going to be doing most of the talking. And if you guys have any questions about the missions or the bodies that we're talking about, please chime in the chat. We'll be paying attention. Danny and I are here for, I don't know, comic relief and to try and sound smart. But
don't put that pressure on me. I'm excited. In the comments is one of my favorite Twitter followers. I think he's Irish, so I don't want to mispronounce how I suspect they may say Sean differently than we do. But and a former colleague has joined as well. So we're going viral via the metric of 2 people in the chat.
Wow! Nice. All right.
Well, Sean makes the most beautiful pictures that I've ever seen on Twitter. So, like, anybody that does not follow Sean Doran on Twitter, like, you guys should be following him for amazing space pictures.
Ian
Sorry, say that again.
Okay.
Oh, Matt Cross, hey. Okay.
Oh, all right. Oh, we're doing all right here.
Great. This is going to turn into like the Western family reunion before we know it. So I apologize to people in the chat who did not go to Western with us. It was a very good time. You all should have been there.
So Tanya mentioned that once a year I would do a kind of summary of what was happening all around the solar system. But once a week, for quite a bit of the year, I would meet with a bunch of students and we would do a weekly kind of summary of things that were happening right then. And this is kind of an outgrowth of that as well. And
I sent out the emails for when we would do that.
Yes, that was a part of the whole thing.
Critical. I was the Jack Swagger of what we used to call Planet Club. You also forgot to mention that I grew a beard to look cool like Phil.
I did notice your beard made a comeback. I'm very excited about that. I don't know if I can compete with you guys though.
Try.
I did get socked in the face though, so I just gotta bunch it up.
Okay.
Did you get in a fight? Right.
I got in a fight with a flat earther, like you do.
Like we do. Okay, we should get on to why our fan.
Right. Yeah, you guys are all here to not hear about beers. I'm sure you're here to hear about space. So let me toss up these slides here.
All right, let's see. Okay, so this is just to get us started. What we're going to do is look at the coming year. So I'm kind of interpreting that to mean the rest of this year and all of 2021. So basically, things that are going to happen during that time frame will get mentioned. And future missions that won't launch for a few more years, I'm leaving them out of it. But we'll just look at what's happening right now and coming up in the next year. Okay, so should we go on? I rarely mentioned the sun when I used to do these old Planet Club things. The sun not being a planet and all, but we do actually have a couple of spacecraft that are studying the sun at the moment. NASA's Parker solar probe, which makes fairly close passes by the sun, closer than I think anything else has been. It's not taking pictures, so this picture isn't from one of them, but making lots of other studies of particles and fields and all sorts of exotic stuff. It's in a very elongated orbit, so sometimes it's close to the sun and sometimes it's out among the planets, and it will make several Venus encounters over time, including one coming up next February. So there'll be some science that would come from that as well. Meanwhile, the ESA and NASA together are working on another mission called Solar Orbiter, which is also it's on its way to the sun, and it took the picture that's shown here. While it was still quite a long way out, it's going to get a lot closer than that, but it already shows lots of interesting little details. The the tiniest little white spots in there are smaller than anything that had been seen before. They're kind of little outbursts on the sun, and each one would be pretty dramatic, but there it is. And this one is also going to make Venus encounters this December and then in August of next year. Venus is key to getting to the sun, because you have to have some way of using the gravity of the planets to deflect you down towards the sun. Otherwise, you're burning an awful lot of fuel to get down towards the sun. And planetary billiards, using the gravitational pull of the planets, is a way of getting down towards the sun without burning fuel. Okay, let's go on to the next one there. Meanwhile, we have a spacecraft on the way to Mercury. Now, this is a geological map, not of the whole of Mercury, but just of the North Polar section. And it's based on data from NASA's MESSENGER mission, which was a few years ago. But we have a new spacecraft on its way to Mercury right now. That's Bepi-Colombo, and it's named after a scientist who actually was the person who suggested how Mariner 10, back in 1974, could actually make multiple passes by Mercury instead of just the one that the mission was planning. So he had a role to play in Mercury exploration, and now he has a spacecraft named after him. So this mission was launched in Japan, built in Europe. It's flying on its way to Mercury, but it'll take quite a while to get there, another 5 years. And meanwhile, it's making a Venus flyby just in a couple of weeks. And it will have a chance to study Venus and maybe tell us something more about that planet. So it's going to be a long time before we get this new Mercury data. Okay, let's go on to the next slide here. And here's good old Venus. And we already have a mission orbiting Venus. It doesn't get a lot of publicity. It's a Japanese spacecraft called Akatsuki. And it's been in orbit around Venus for 5 years, studying atmospheric physics and chemistry. So I think there's a chance that this mission, and also maybe Bepi-Colombo when it flies by, will help with this interesting story that's come out just recently about an unusual gas in the atmosphere of Venus detected by telescopes on Earth, a gas called phosphine. And of course, there were lots of stories about how this means that there must be life in the atmosphere of Venus. It doesn't mean that, but it's telling us that there could be something interesting going on that is definitely worth looking at more closely. And these Akatsuki and Bepi-Colombo may be able to give us some of that information there.
You see what that is? Canal.
Does Akatsuki have an instrument on board that could try to verify the phosphine measurement?
I'm afraid I don't know that. I think it does, because it is doing atmospheric chemistry work, but I don't know the details of its instrument or whether it will be sensitive in the right places in the spectrum to do that. But Bepi-Colombo, I believe, does have instruments that would help with that. So we'll see. Okay, well, shall we move on there? Then we come to the moon, and I've got a few moon missions to talk about. This is a picture taken by Lunar Reconnaissance Orbiter, LRO there. So here I'm just listing a couple of things that are already in orbit. LRO, Lunar Reconnaissance Orbiter, NASA's mission, which has been in orbit around the moon for more than 10 years. It's imaged almost the entire surface at much higher resolution than we've had before. It's a fantastic mission, and it just goes on and on, providing more data. And you might say, well, when they've imaged the whole surface, why bother doing it again? But what we're actually getting out of this mission is almost the whole surface of the moon, imaged with morning illumination and afternoon illumination and noon illumination and so on. So you can get to see the same place with multiple different kinds of illumination, and that really helps to understand what's going on the surface, to separate out sort of light and dark markings from topography, for instance. And also, by taking pictures of the same area repeated, you can look for changes. So they've seen new impact craters forming, all sorts of good stuff. There's a mission called Themis Artemis, which is doing space physics stuff, 2 spacecraft orbiting the moon. And then Capstone is going to be launched just in a few months, and it's going to orbit the moon as well, but in an orbit like the Gateway little space station that will be used to support Artemis moon landings in the future. So it's going to launch soon and then spend some time orbiting in the Gateway orbit, which is a rather unusual orbit. And they want to basically check out that it will work the way their predictions say it will. And another orbiter that we have at the moment is Chandrayaan-2. It's an Indian orbiter. It's mapping the moon. It tried to put a lander on the surface last summer, but it crashed. So it wasn't successful, but India is working on a replacement for that, a new lander that will fly in a couple of years.
So with LRO,
yeah,
you've got the wide-angle imager taking these huge swaths of the planet to make these different illumination mosaics. We also have the 50-centimeter narrow-angle camera. Do you know how close we are to getting global coverage of the moon at 50-centimeter resolution?
Yes, actually, when I mentioned nearly global coverage, I was talking about the narrow-angle camera, and not the wide-angle camera, which is definitely mapped the moon in many different illumination conditions repeatedly. But the narrow-angle camera has imaged almost the whole surface of the moon multiple times with different illumination as well. So we have an absolutely unbelievable data set from this mission.
That's pretty incredible, seeing as you can't just go and download free data of the Earth at 50-centimeter resolution.
No,
that you have nearly the entire moon. That's amazing.
Yeah, that's right. It's great. Yeah, okay, let's move on there. So another mission that's operating right now is Chang'e 4, the Chinese lander, which landed on the far side of the moon, the first thing that has ever landed on the far side of the moon. A few things have hit the far side of the moon, but this is the first thing to land. It's got a little rover. If you're going to be on the far side, you've got to have a relay satellite to relay communications, because we can't communicate directly with it. So they have that in place. It's quite a sophisticated operation. And U-22 has been driving around. It's driven about 550 meters as of a few days ago. Slightly updating my number there. That's not very far. It's been on the moon since January of last year. So it's 22 lunar days, 22 months in terms of lunar days. And it's only gone 550 meters. So that sounds like it's not so great compared with, for instance, the old Soviet lunokhod, which drove many kilometers, tens of kilometers, one of them. But the amount of science that U-22 is doing is much greater than what came out of those old rovers. So it's not a problem that they're only going relatively short distances. Okay, and coming up, something that I think will be a very exciting mission, I hope it's successful, is Chang'e 5. This is China's first sample return mission, and it's going to launch this November, probably right about the end of November. It'll fly to the moon, it'll orbit, it will land, it will put a drill down into the surface and drill up a sample and use a robotic arm to scoop a sample. So it has basically two redundant ways to take a sample, which is quite a good idea. And they will then be fired back to Earth. The top of this spacecraft mock-up here is the bit that comes back, and it comes back up to orbit, where it joins up with an orbiter, puts the sample in a return capsule, and the return capsule is then released to fly back to Earth. So this is quite a sophisticated operation. Hopefully it's going to be successful. Of course, we have samples from before, from Apollo and from some old Soviet spacecraft, but this is going to a very different place. One of the very young lava flows, I said very young in lunar terms, might be about 1.5 billion years old, but that would be only half the age of the youngest samples that we've seen before. So geologically, that's going to be very significant. That whole mission will happen quite quickly. They land, they do the sampling, they return, all within a week or so. We don't have to wait many months like with the rover for the results. Should we move on? And also coming up in this coming year, going into next year, we'll see the first missions from the Commercial Lunar Payload Services program. This is NASA buying space on commercial landers, and various companies are building these landers. Next year, 2 of them will fly, so I'm including them here, but there are a couple more the following year and a couple more the year after that, and more planned. So this is going to be an ongoing thing with a couple of landings every year if everything goes according to plan. The first one that we'll see is by a company called Astrobotic from Pittsburgh, and they will fly to the moon and land in the place that's illustrated here in that white ellipse, which you can see is almost featureless inside the ellipse. That's what you want for a good landing site. It's in a place called Lacus Mortis, which unfortunately means Lake of Death, but we have to hope that actually the spacecraft doesn't die. It lands successfully and does its thing, and it's carrying lots of payloads, NASA payloads and commercial ones. All sorts of interesting things will come from that, that will be in the summer, and then later in the fall, another company called Intuitive Machines, who operate out of Houston, they will fly to a place called the Aristarchus Plateau, a place with lots of interesting volcanic rocks, pyroclastics, volcanic ash. First time that we will have landed in a place like that, although there was some of that at Apollo 17's site. Anyway, that's going to be a unique landing site as well. So these are going to be really interesting missions, carrying NASA instruments and things from other people as well. So,
where is this in a bigger scheme of the moon?
Well, if you were looking at the front face of the moon, Astrobotic is landing sort of up towards about the 2 o'clock position on that clock face and about halfway out to the edge, and Intuitive Machines is landing a little bit north of the equator and more to the left-hand side of the moon's face if you were looking at a full moon.
Do we know what these payloads are going to be in terms of like instrumentation?
Well, they've all been listed. There are all sorts of things measuring composition and dust and radiation, and there'll be laser reflectors to reflect laser beams from Earth. There are probably quite a few more that I can't remember right now, but I don't have those lists in front of me, but they've been released.
Okay, cool.
Yeah. Okay, shall we move on there? And so also coming out will be Chandrayaan 3. I've said here that they'll launch in mid-2021, but it looks like that will go into 2022 now. However, it's the replacement for Chandrayaan 2's lander, which crashed late last summer. So it will be a lander, it will have a rover, and it will land in a place quite far to the south. That little picture of the moon is the place where the spacecraft went splat on the surface, the lander, last year. So hopefully this one is going to go to pretty much the same place, but hopefully it will survive and operate properly. And it's going to a high southern latitude. It's not at the pole, but it's about 70 degrees south, further south than anything else has ever landed. So that'll be an interesting thing to observe.
Was that always the plan for 3, or are they doing that because 2 splatted?
3 is specifically a replacement for 2, so because 2 crashed, they're just repeating the mission and going to the same place. Yeah, and India has other moon missions in the works. It's looking at for the future. So there'll be an ongoing program of lunar exploration from India as well. Okay, so we go on. And also Russia. Russia is getting into the act, if everything goes well. This is an illustration from the Space Research Institute in Moscow.
The actual spacecraft, though.
They need to invest in some graphic designers.
Oh, that's beautiful. That's the best spacecraft we've seen so far. Let's just do the rest of the hour on that.
Very Soviet.
Yeah, so it's called Luna 25. Luna 24 was a little while ago. It was in 1976. It was the last of the old Soviet landers, and that was a sample return mission. So now they've instituted a new program, and at first they called this one Luna Glob, which meant means globe, and it was because it was supposed to be a kind of a global survey of the moon. They've changed the function of it now, so it's just going to be a lander. But it's going to land again in fairly high southern latitudes, not too far from where the Indian spacecraft will land as well. It's supposed to go next year. I wouldn't be at all surprised if it was delayed a bit further, but that's something that we might be looking at next year as well. Okay, let's go on. Okay, and then there's Mars. Well, there's tons of stuff happening in Mars. This illustration is not quite to scale, I have to tell you, not quite to scale here. The spacecraft are really a bit smaller than that. But there are 6 active orbiters orbiting around Mars right now. It's hard to remember.
I want Tanya to name them by the picture.
By the picture. I mean, close to midnight is Odyssey.
Right.
Yeah, Odyssey still works. It's pretty amazing. Like, that was when I was in junior high school, something like that. I think I was in high school. Yeah, and it still works.
Well, the rest of them just go line clockwise in the order that I've listed them there.
I was going to say, I think they're actually just in order. Yeah. So it's not very difficult.
But yes, so there's an enormous amount of information being transmitted down from Mars every day. 6 active orbiters, most of them doing quite a lot. I have to say the one at the bottom of my list, which is at the sort of like a 10 o'clock position there, the Mars Orbiter Mission, or MOM, that's from India, and it has a, shall we say, a lower workload, but it's still taking pictures. It takes beautiful global scale images, I must say. They're really beautiful. So, and they're good for mapping out the distribution of things like dust storms and clouds and so on.
So these old ones, like Odyssey and Express, and even MRO, like, what are they doing? Are they just the same thing?
Well, they've always done. They're imaging, and they're also functioning as data relays for data relays for surface missions. So right now, Curiosity and Insight are transmitting through orbiters, and different ones as circumstances require it. Insight was sending stuff through TGO, the European orbiter, for instance, recently. So it just depends which one is in a good position and has time to do a relay.
Do you have a slide on TGO?
No, I don't.
Has it found anything?
It's taken lots of great pictures.
Well, that's nice.
So very political.
Video.
Tanya, do you know anything about TGO?
I have only really heard, or I've only really seen the pictures, like from CASIS, the color and stereo surface imaging system, but I'm not sure I've heard any methane results.
Okay, so I think I do have one result to report then. One of the things they were especially looking for was the gas methane in the Martian atmosphere, which has been suspected from a variety of other measurements, and it's been measured. Curiosity measures it from time to time, for instance, including big annual spikes, which are not at all understood. But my understanding is TGO, which is exquisitely sensitive and ought to be able to detect the methane, has not found it. Or perhaps they've found very small amounts, but I don't think they've found as much as they were expecting to.
Good to know. Good to know. Do you want me to move on?
Yeah, let's move on there. Because we have our surface mission here, Curiosity, which has been on the surface for 8 years. It's driven about 22 kilometers. It's in the most amazing landscape. You can see this mountainous landscape at the top. And it's been driving across plains and then through foothills, and it's coming up towards the bottom of this mountain range, where I'll try to find a path up into the hills fairly soon, another year or so. It's been looking for evidence of past habitable environments. It's not specifically looking for living things or fossils even, but looking for places where things might have been able to live. So if you can find, for instance, evidence of water, and then evidence that shows that water was sitting around for quite a long time on the surface, and may be evidence that it wasn't sort of too salty or poisonous, with dissolved minerals, then you find something that might be habitable, and that's what it's looking for. And it's found quite a bit of evidence for suitable conditions for life, just not necessarily something that's living now. They're just looking for the places where the environment might have been suitable a long time ago. It's probably got about 3 years more to operate, and it's going to be climbing into that mountainous terrain. And just in the last few weeks, it's been drilling samples from a place called Mary Anning. And if you know who Mary Anning is, good for you. She was the famous fossil hunter who discovered some of the first specimens of important dinosaurs in the south of England.
Yep.
And there's a new movie coming out about her, so you should look out for that. Anyway,
where does
sorry.
Where does the 3 years remaining of operations left come from? Because the battery will last longer than that. Is it because the wheels are falling apart, or like where's that estimate from?
It's the battery charger. It has a radioactive source that trickles energy into its batteries. Sometimes people call it a sort of a nuclear powered rover, but it's really only the battery charger that's nuclear powered. But it has a half-life, and the stuff is running down, and power will become much more limited over the next few years. And there'll come a point where they don't have enough power for it to continue operating very successfully. Maybe they can go a bit longer than 3 years, but they are looking at a limit to this mission.
I know last time, it's been a couple of years, but so the arm had initially some sand in its joint, right? And then the drill was acting up. How's the arm and the instruments holding up?
Well, everything's holding up fine. The drill did fail, but they found an ingenious workaround. The drill was supposed to operate in a certain way, and they found a way to make it work in a different way. It's not really quite as effective, but it still gives a usable sample. And the important thing for that sample is that it's a fine enough powder that it can be put into the analytical instruments on the rover. And they found a way to make that work. So it's fine. And the arm is working. So everything is good right now. Okay, let's move on to InSight, a geophysical lander that landed nearly a couple of years ago. That means it's been on Mars almost a full Mars year of operations. We're practically at one Mars year. And it deployed a seismometer, which has been giving nice results. It's so unbelievably sensitive that when one of the little moons of Mars overflies the site and its shadow passes over or near where InSight is, the change in heating of the surface causes it to tilt slightly. And I ask you to imagine how tiny that tilt would be. And the seismometer can detect it. So it's exquisitely sensitive, and it's working well and giving interesting results. And it's enabled them to measure sort of background seismicity of Mars quite well, and also some larger quakes. The impression I have is that the quakes that they're detecting are being caused by landslides on steep cliffs some distance away.
I tried logging into the chat so I could trash talk with Matt and Ian, but I didn't realize. I knew it would kick me out, but I forgot that I was sharing the PowerPoint. So I'm sure you ad-libbed effectively, but I'm back and I can't trash talk, but I'll try on my phone.
So I've got to ask, there's a new show on Netflix called Away with Hilary Swank, and oh gosh, I want to ask a question, but I don't want to spoil the show for anybody. So if anybody has not finished watching Away yet, cover your ears for the next, 2 minutes. And part of the mission, or part of the show, they try to figure out if a certain mission successfully landed on Mars or blew up like as it was entering the atmosphere.
Mhm.
And the clever workaround they come up with is that they use InSight to see if InSight heard the sonic boom from the spacecraft entering the atmosphere. I'm wondering what you think of this.
Well, it might be possible. I hadn't thought about that, but if it can detect the ground tilting because Phobos's shadow passes over it, it might detect a big sound wave from something as big as that, especially if it wasn't too far away. Now, InSight isn't too atrociously far away from where the Mars 2020 rover will try to land, so it's conceivable that that they will get something from that. That would be very interesting to see.
We'll have to put that on folks' radar. That would be pretty cool.
Yeah. Now, InSight also has a heat flow probe, which is not deployed properly, and they're still struggling to get it deployed. It's supposed to bury itself deep down in the surface, several meters down, and right now it's only just underneath the surface, and they're having trouble getting it to go any further. So it's not properly deployed. It can give a tiny bit of information, but not at all what they really want from it. So they're still continuing to try to get it to go downwards.
Does it show any good?
I just finished it yesterday. It's more like a drama in space than it is a sci-fi show. I was not a fan too much in like the first couple episodes, but it gets a lot better. It deals a lot with kind of the emotional side of space exploration and like what the families of the astronauts would deal with and the astronauts like being separated from their families in a way that I don't think a lot of shows have ever done before. It's also it's an extremely diverse cast. It's the only show I've ever seen with like more than one character with a visible disability portrayed. They've done such a good job with a lot of different things, and some people didn't like it very much. I think maybe those folks were expecting more science fiction than like space drama, but by the end of the season, I was actually quite pleased. I thought it was pretty good.
Okay.
You know who doesn't have any emotional problems on the way to Mars? Robots.
As far as we know.
I don't know. Hal was a bit unhappy. Okay, let's move on here. So looking at missions that are on the way to Mars right now, Perseverance, NASA's big rover, will land next February, and it's the first step in a sample return mission. So this one is going to drive around. It's got a really interesting landing site. It's going to drive around and sample rocks that have come out of a river delta and lake sediments and things like this. It will store them and cache them on the surface, leave them on the surface to be picked up. Later on, another mission will come into the same place and send a rover out to pick up those samples, and we'll know where they are. We'll get good records of where they are. They'll be picked up and brought back and launched into orbit around Mars, where they will team up with a spacecraft that will bring them back to Earth. So this is the first step, collect the samples. And it also, as I say, right at the bottom there, it's got a helicopter. This tiny little thing that's right at the front in that picture. It's like a little kind of drone, if you like, with two counter-rotating rotors on top of it. And it's really an experimental thing. It might only fly about three or four times, but it's going to experiment with flying in the thin atmosphere of Mars. Take some pictures. I don't know if it's doing anything but taking pictures. But there are multiple things that it could do. And you could imagine, for instance, that it could fly ahead and look for obstacles. And if there aren't any, report back. And then they could plan a longer drive because they know there aren't any surprise obstacles further out and they can see clearly. And also, if they were driving along the base of a really steep slope, it could fly up and look at the top of the slope or look at layering in a cliff that would be completely out of reach of the rover. So there are interesting things it could do, but this is an experimental one. And if it works, then we might see more of these in the future.
And a cool fact about the helicopter is that since it was built so much more recently than the design of the rover itself, the rover's building on a lot of heritage from Curiosity, the computers, like the processing power inside the helicopter, is actually more than the rover itself. It's using a lot more new components and a lot more commercial off-the-shelf components compared to the rover. So it's a cool comparison of like recent agile aerospace type stuff versus like big heritage instrumentation.
Yeah, that's interesting.
It only communicates with the rover, right? Like it obviously won't have any ability.
Yes.
Yeah. So it's gonna be interesting. It's also gonna like Perseverance is gonna like lay it like an egg and then just drive away, and then because it's latched underneath in like a kangaroo position underneath, and they're just gonna drop it, and I'm sure it'll drop fine, and then it'll take off. Hopefully.
Well, they have to drop it and kind of treat it like it's a bomb and then drive away because they don't want it to pick up and then like accidentally smash into the rover.
Mm-hmm.
No, the rover's far more precious cargo.
Ooh, some helicopter people might disagree with that.
There's no helicopter people.
Oh, if you're a helicopter person, chime in the chat right now.
On Earth, sure.
Oh no, I mean on Mars. The Mars helicopter is getting a lot of love from people. It's pretty cute.
Yeah. Oh yeah.
It's like the new Sojourner.
Yeah. Oh yeah, and it's called Ingenuity, right? Yes. Yeah. Okay.
Goody.
Okay, let's move on.
I'm skeptical.
To another new mission that's already on its way. This is it's called Hope. It's an orbiter. It won't land on Mars. It's an orbiter, and it's from the United Arab Emirates. It's intended to inspire youth and to develop the aerospace industry in the UAE, and to observe the atmosphere of Mars from a high orbit. So it's going to be doing sort of synoptic studies of the whole atmosphere with a really nice instrument set, including a nice high-resolution camera that is going to give absolutely mind-boggling pictures, I think beautiful pictures of the whole globe. It was launched by Japan, and it will get to orbit in February. So we have that to look forward to. And now let's move on again to the third mission that is on its way to Mars right now, Tianwen-1. This is China's moon lander and rover. Actually, it's an orbiter as well. Orbiter, lander, and rover from China. It's their second attempt at a Mars mission. The first one was going to be launched piggyback on a Russian spacecraft, which was lost in a rocket failure. It got into Earth orbit and then never got out of it and burned up in the atmosphere. So now they're doing it on their own. This was launched in July. It's going to go into Mars orbit in February. So February next year will be a busy month as Perseverance lands and Hope and Tianwen-1 go into orbit. And the Chinese orbiter will then image their landing site, and they've got a landing region. They're going to choose the exact site they'll go to in it. And then they'll land in approximately May. And they have a lander and a rover. Hopefully everything will go successfully there, and we will have at that time 3 rovers driving around on the surface of Mars, the Chinese one and Perseverance and Curiosity, and of course InSight working away as a static lander. So it's going to be a fairly busy surface of Mars as well as a busy Mars orbit.
So where's it going?
So
it's not like Mars, obviously.
So this is going to a place that is actually not too far from InSight. It's kind of halfway between where InSight and Curiosity are. They're close together, and where Perseverance will go. It's Southern Utopia Planetary, and it's actually quite close to one of the sites that was considered for Viking way back in the 1970s, a site called Amemphes.
And so that'll be the first time there's 3 active rovers on a surface, because Mars would have missed that.
Yes, that's right. The first time there will be 3. There have been 2 rovers. Of course, Spirit and Opportunity operated for a while, and then after Spirit packed up, Curiosity came along, so it was Curiosity and Opportunity, but we've never had 3 before. So this time, if all goes well, we'll have the Chinese rover and Perseverance and Curiosity all working together. So I'm going to be pretty busy trying to keep up with maps of all of these things. I hope nobody launches any more.
At least the maps for Tianwen will be easy.
Well, you say that. We'll see. Anyway, okay, let's look at some asteroids here. So first, we've got an asteroid mission called Hayabusa 2 from Japan. JAXA is the Japanese space agency. Last year, it collected samples from the surface of this asteroid, the asteroid Ryugu. It's about 900 meters across, and it has a kind of slightly diamond-type shape that you can kind of get a sense of from that map. And this spacecraft is on its way back to Earth, and it will land in December of this year in Australia. So hopefully we'll have samples of an asteroid to look at and analyze at the end of this year. And the main spacecraft will avoid the Earth's atmosphere. It won't burn up. It will skip by, and it will fly past two more asteroids some years down the road. So quite an interesting mission. And the picture at the bottom shows what the asteroid looked like, and then the other picture shows what the surface looks like from a little lander. That's a German lander that was dropped by a Japanese spacecraft on this asteroid. Took this great picture. All right, let's move on again. Oh, whoops, back.
Wait, yeah, this one. Didymos.
No, back.
Oh, I wanted to talk about Didymos.
We'll talk about Didymos in due course. So here's another asteroid that has the same look. It's roughly the same shape, but it's only half the size. NASA's spacecraft called OSIRIS-REx. And OSIRIS-REx is a ludicrously contrived acronym for something that I'm not going to attempt to say. But it's at the asteroid now. It's going to swoop down and pick up a sample next month, and then bring it back, and it will get back about 3 years from now, landing in the desert in Utah. And they've just recently identified that they could do an extended mission. So after they drop off the sample, that comes back in its own little return capsule, but the main spacecraft can fly past Earth and onto an interesting asteroid called Apophis in 2029. And some people might recognize the name of this asteroid because it's one that has been widely talked about as something that might hit the Earth. There are often stories about things that might hit the Earth, but this is the one that comes closest to maybe hitting us. So it's being intensively studied. In fact, there's a workshop on studies of Apophis coming up in a little while, later this year. But this spacecraft has a chance to actually rendezvous with the asteroid and go into orbit around it. And I think it would be active in orbit around the asteroid when it did its very close approach to Earth. And we don't really expect it to hit, but it'll be a very close approach. And should be quite an interesting event.
Ian has suggested that we take out a portrait. We could smash OSIRIS-REx into it. I see what he's saying. That would work. I have a bad echo right now.
Okay. One other thing, that the lower right picture in my set of pictures there shows the asteroid with a little puff of debris coming out up above it, up towards the sort of 10 o'clock position. Every now and then, some little bit of the asteroid will puff out a few little specks of small particles, little bits of dust and small particles. Most of them fall back down to the surface, and a few probably escape. But other asteroids are known to be active like that, but this is the first time that we've actually seen one close up. So they're able to map out the places where these events occur, and they're kind of scattered all around the asteroid.
So I have to share an adorable story about this.
Okay.
Oh, I think the echo might be coming from your computer. Phil, try going on mute for a second. Oh, wait, it went away. Maybe it was Danny.
It wasn't me. See, it's fixed.
Weird. Okay. I don't know. Anyway, okay. Adorable story about OSIRIS-REx. So my friend's daughter is obsessed with space. I think when this was discovered about the sputtering, she was 7 or 8 years old. And she wanted to try to recreate how she thought this was happening in her living room, and decided to do so by taking a cone of paper and filling it with pop rocks, and then spitting water into it and letting them launch all over the living room. Because she said, well, if you mixed water, then maybe this is why they were exploding. And I found out from this with her mom texting me saying, well, we need more pop rocks.
Great. Maybe this asteroid is made of pop rocks.
Ooh, delicious.
Well, I was reading, so I didn't know a lot about, I still don't know a ton about the idea of like asteroid families and the mixing between them. But there's evidence of components of Vesta on Bennu.
Yes, that's right. And if you look at the original of this map here, which is posted on Unmanned Spaceflight, then I show where those fragments of Vesta are, as well as where the sites are that are ejecting debris. So you can check it out on the original of that map. So the idea really would be that something big smashed into Vesta and threw chunks out into the asteroid belt, and we call those vestoids, little bits of Vesta, which are themselves small asteroids. And one of them that was probably relatively close to Bennu then got hit by something else that knocked bits off it, and some of those bits have been accumulated on Bennu. Yeah, so interesting. All right, now let's come on to this mission. So this is DART, the double asteroid redirection test. Now, people are interested in the idea of how you could what you could do about an asteroid that was found to be on a collision course with Earth. Would we have any way of protecting ourselves? And one way that you might consider doing it would be to smash something into it. So it's conceivable that could work, I guess, but we don't really know much about what effect it would have. Ideally, what you want to do is not just break the asteroid up, because then you just instead of having one big asteroid hitting Earth, you have a whole bunch of little bits, and it might not be very much better. But if you could hit the thing kind of sideways so that you could knock it sideways a bit, then you might make it miss the Earth. So that's what they would try to do. And this is an attempt to learn how to do that. They're not going to hit the main asteroid itself, which is called Didymos. They're going to hit its little moon. Quite a lot of asteroids have tiny moons. And at the bottom, there's a row of radar images showing the asteroid itself with its little moon as a row of little spots running just north of it. Looks like they've lost the picture there. But anyway, the asteroid has a little moon. So the idea is they're going to fly this spacecraft past it and smash it into that little moon and see if its orbit changes. So we can actually measure its orbit very, very precisely.
You there, Phil?
Oh, yep, I lost him too.
Oh, you might have froze. In the meantime, I was rapidly trying to see if I could make an acronym out of AFLEC that they should have named the spacecraft. DART is okay, but AFLEC would be way better for an asteroid redirection mission. So Phil has dropped off. Do you know anything about Didymos?
I know nothing. You were excited to talk about it, so it sounds like you should know something about it. Or were you just hoping to learn more from Phil?
No, the first thing I learned of it was when I accidentally went past it and saw the word Didymos. So Daniel Yelnt is asking, will it hit it or sideswipe? My understanding is that it would be a direct impact. Phil can answer that. This is a while from now, though, 2022.
There we go.
Okay, I'm not quite sure how much of that we know. But to summarize anyway, the spacecraft will hit the little moon, and then people will measure the change in the moon's orbit, which we can do quite sensitively from Earth using radar. And so we will be able to figure out whether this is a feasible approach to protecting Earth. Hey, Ian. Yes. Okay, so also it will release an Italian CubeSat, which will image the actual impact. So that should be fun as well. And ESA the European Space Agency has a mission called Hera, which will visit the asteroid later and be able to observe the crater that was made and the aftermath in much more detail, but that'll be later on. Okay, shall we move on again here?
Yeah, as long as we don't lose you again.
Okay, try not to. So also launching in October next year, so a bit more than a year from now, Lucy, which is going to be a wonderful mission that will launch from the Earth and go into a big elliptical orbit that will take it out from Earth's orbit out to Jupiter's orbit. And it's arranged so that it will fly through the cloud of Trojan asteroids and actually visit several of them. And then it comes back to the Earth, and then it flies out again. And this time when it gets there, the other cloud of Trojan asteroids is in the right place, and they get to fly past one of them, but it happens to be a double asteroid, two quite big chunks orbiting each other. So we end up actually with a total of 8 asteroids visited here. 2 of them are double. So it's going to be quite an interesting mission. So that launches next year. And next slide. So we're coming to the near the end here. So this is Juno. Juno is a great spacecraft that's orbiting Jupiter. It's been orbiting for several years now. It's taking lots of pretty pictures, but that's not really the main purpose of it. The camera was very much a kind of afterthought on this mission, used for public outreach, although it's getting great pictures of clouds and doing some really good science itself. But the other instruments are studying the environment of Jupiter, the gravity field, and radiation, and they're using infrared to take pictures of the auroras and the clouds, so we can see the heat escaping from the hot interior of Jupiter coming up through the clouds, and you see high clouds in silhouette against the hot interior. Quite good pictures. And that funny red and yellow picture up at the top there is the volcanic moon Io, imaged by that infrared camera. So they're able to do amazing imaging, monitoring of the volcanoes of Io like that. Now, Juno is actually coming close to the end of its primary mission, the mission that it was originally designed for. That would end next year. So they're applying to do an extended mission. And the extended mission won't be exactly the same, because the orientation of the orbit is changing gradually over time. And in the extended mission, they will make close flybys of several of the moons. So we're going to have a lot of interesting moon science that hasn't come from this mission before, including close flybys of that volcanic moon. So there should be a lot of interesting stuff to see coming up.
So if we do get that extended, the echo's back. If we do get that extended mission, it's obviously a good thing we attached the optical camera. Like, are the other instruments, because they're just like a magnometer and radiation or something, are those going to be useful for the moons too?
Well, the infrared camera will definitely be interesting, definitely. But also, for instance, Ganymede has a magnetic field, the only moon known to have a significant magnetic field. So its interaction with Jupiter's magnetic field is going to be extremely interesting. We've never seen a magnetic moon inside a planet's magnetic field before. So the other instruments are going to tell us about things like that too. So actually there's a lot of good stuff that will come from all of these instruments, and it'll still be doing its thing with Jupiter too.
And for those who don't know, one of the people in the chat, Sean Dorian, I think his specialty, I don't know to speak for him, is recently been Juno images, because I had one as my background for a while. Jupiter will end you. I assume he's referring to hours sitting in front of a processing screen. But yeah, I had it as desktop for a while, one of his images. But after a while, Jupiter is also kind of like scary. Like, it's not I don't know, maybe that's just me, but I find it as like a daunting thing to look at constantly.
Well, yes, it is rather daunting, but the pictures are so spectacular, and Sean has done fantastic work with them. So it's great to see that. Okay, let's just move on. This will be my last slide as we kind of come to an end here. The Kuiper Belt, the outermost part of the solar system. Right now, we don't have any spacecraft doing things at Saturn or Uranus or Neptune, but we did have this wonderful spacecraft, New Horizons, which flew past Pluto a few years ago and took pictures of Pluto there and its big moon Charon and a couple of little moons, Nix and Hydra. And then 3 years after that, it flew past this funny object, Arrokoth, the two-lobed object below it. The first time that we'd seen one of these little things further out than Pluto. It's only about 40 kilometers across. So now New Horizons is speeding out through the Kuiper Belt. It doesn't have any other targets right now, but they are looking out just on the off chance that they might see something that they could reach. They have a little bit of fuel left, so they could steer possibly to a new target if it wasn't too far off their trajectory. But meantime, they're also using the cameras to take pictures of other Kuiper Belt objects as they pass, reasonably close by. These are things that we've already discovered from Earth, so we know where to look, and this can look at them, but it's seeing them from a different angle. And by looking at things at different angles and looking at the way they reflect light at different angles, you learn quite a lot of interesting stuff about the texture of the surface and this kind of thing. So they're able to study these things in a way that we can't do from the ground. And also they can take pictures over a period of time, lots of pictures of the same thing over a period of several hours or days, and try to determine its rotation period. So they're doing that kind of work with these distant KBOs better than we can do it from the ground at the moment, for the most part.
Is there any estimate in terms of like how much fuel New Horizons has left? How many more KBOs they can visit?
Realistically, it could only do one, and that's it, assuming that they find one that's reachable within a few years. But they are looking. There's a sort of they don't need very much fuel during regular operations, but they might need to use quite a bit of what is left to deflect their trajectory to take them close to something if they find one in the right place. That would be the main user of fuel, I think. And there's a chance that they could do that.
And then it might just turn into like a Voyager just floating off.
And then it will be a Voyager, and it will just fly into the solar system. Yeah, that's right. And it's well equipped to study the outermost part of the solar system. Yeah, that's right. Particles and fields mostly, but lots of interesting stuff.
Cool.
Okay. So yeah, it's going to be busy next year. Quite a lot of good stuff happening.
That's great.
Nice. So yeah, go ahead, Tanya.
I was going to say, we did have some questions in the chat. Sean had a question for you, Phil, in terms of digital terrain models from LROC. Do you know if those are available anywhere?
Oh, yes, they are. You have to go to the LRO. Well, I suppose they might be available through PDS, but I normally look on the LRO camera website, LROC camera website, where they have a big data archive. And you can search in that, and they have a lot of DTMs that are there, and ortho photos that have been corrected using those DTMs. There are quite a lot of them. So yeah, they do have them. They are available. There's a lot of stuff available there, and good stuff from the polls as well.
Tanya, do you want to throw up Ian's question?
I was going to say, I think that's for you, Danny.
That's not for me. That's for Phil.
All right. What do you think about that? Okay, I vote for the ocean. I know people are talking about interesting things in the atmosphere of Venus. I get that. But I think there would be a lot more to learn from the Europa Ocean, personally. However, I realize that there would be people who would disagree with me.
I think there's certainly way more the probability is higher that there's life in the ocean of Europa than the phosphine in the atmosphere of Venus being from
I
life.
think so. Yes, I think so.
We're gonna get like riots from the Venus community watching this on Twitter. Sorry.
Yeah, I would agree too, because the Europa water, or whatever it's going to be, is more likely to represent something weird than the Venetian atmosphere. We kind of know what's in it. Like, obviously, we've discovered some things we didn't expect. But yeah, the amount of unknowns, likely with one sample versus the other, I would lean towards the one that has almost entire unknowns, which is the Europa subsurface ocean material.
Yeah.
So,
Yes.
yeah, good timing, Phil.
Yeah, I guess, are there any last burning questions from folks that are hanging out in the chat right now?
I'm surprised none of my students said, if you could plan a mission anywhere in the solar system, what would it be, and what features would you study, and which instruments would you use for those features? But
Whoa, you want me to answer that?
no, that's all right. But yeah, I mean, while people are maybe thinking, or while we wrap up, we're still going to be doing this, once a month, and we've been thinking to kind of recreate the space club we had at Western. We would kind of do the first half hour. We'll be Phil talking about what's been going on in the solar system, assuming things have been happening and Phil's had time to kind of coalesce them. And otherwise, it'll be, the other half, the second half will be the three of us digging into something, a specific mission from history, or something else, or a feature, or some boring Mars gully or something.
Okay.
Only one gully, just one.
Just one?
So pick your favorite one. You said Mars Gully, so only one, singular. Just gotta pick your
Oh,
favorite
I thought you were
one.
implying your PhD was a single Mars gully. Which,
All right.
yeah.
Yeah. So if anybody has requests that has dialed in on things that you want us to talk about, put them in the comments. You can leave them here. You can catch Danny and I on Twitter. Our Twitter handles are in our names here. Let us know what you want to see. And yeah, we'll be here every month. So hopefully we'll see you again. And thanks again,
so
Phil,
much.
for your time, as always.
Okay. It was fun.
Thanks,
All
Phil.
right.
Thanks, everyone, for joining.
Night, everybody.
All right. Bye-bye.